Hey guys, this is our first go around for a lesson that we're going to be working on in 8th grade math out of chapter 1, section 1, the very first one. So hopefully you watched the helpful reminders video, just to remind you as to what you should be doing during this lesson. As we go through this one, I'll try to prompt you to remember to do certain things. But as the year progresses, I'm going to stop prompting those things, and I'm hoping it just kind of becomes a natural habit for you. So let's go ahead and get started on this. First thing is, today we're going to be talking about rational numbers. Here you can see we have a couple different vocabulary words that you need to copy down. So right now what you would want to do is pause the video and copy these into your notebook. When you're done copying, unpause the video and listen to my voice. Okay, so let's get going here. A rational number is a number that can be written in, should say form right there, there's a typo, in the form a over b, where a is an integer and b is any non-zero integer. Every rational number has a decimal expansion, which can be found by dividing the numerator by the denominator. This is just to say that a rational number is a number that can be written as a fraction. That second part where it says b must be a non-zero number, that's important because you can't have zero on the bottom of a fraction. And that all goes back to not being able to divide by zero. You may have heard that before. That will come up a lot more as you go through Algebra 1 and into Algebra 2 and so on. But every rational number has a decimal expansion. In other words, it can be written with a decimal. There's two ways this comes up. The first way we're going to talk about is a terminating decimal. A decimal that stops is called a terminating decimal. So it may be like 0.25. Or it might be something like 0.344 or anything like that where it stops and it does not continue on. That is what a terminating decimal is. So let's move on. Okay, so how do you write a terminating decimal? Well, here we have a problem that we're going to go through. It says, in baseball, a player's batting average is his number of hits divided by the number of times at bat. Remember, this bar right here in a fraction means division. A batting average is rounded to 3 decimal places and written without the leading zero. Find the batting average of a hitter with 36 hits and 125 times at bat. Okay, so here we don't have enough room, so let me get myself enough room. So there's a couple ways to do this problem. First and simplest way to do this is with a calculator. But what if you don't have a calculator? Well, let's go back to that. So we're looking at the number of hits. So let me get my handy dandy writing stuff here, and I think yellow probably shows up the best. So we're going to have 36 over 125. Well, as I said before, this bar right here, this means division. So the easy way to do this problem in your calculator would be to do 36 and then hit the division button and then by 125. But what if you don't have a calculator and you need to do this particular problem? So let's look at that. So you're going to start out with this symbol. You may not have seen that in a long time, but this is what you learned to do long division with. So here I have 36 inside, and that's being divided by 125. And the way that you do this is that you start out, and first of all you say, okay, 125 is too big to go into 36. I got an issue there. I need to do something about that. So we put in a decimal, and then we add a zero. Whoops. Then we add a zero to that value. This zero does not change the value of the 36. This is actually called annexing in a number. So we have 36.0, but we're going to treat that like it's 360. Remember, this decimal comes straight up. So there's our decimal. We have 36 divided by 125, but again, we're treating that like 360. We're going to see how many times does 125 go into 360. There's a couple ways you could do this if you don't have a calculator. You could count up by 125. So I'd go 125 is 1 time, 250 is 2 times, and then 375 is 3 times. So that's over 360. So I know it goes in 2 times. So I go ahead and I do 2 times 125, which is 250, and I put that value right there. Now, if you recall, you would go through and you subtract these values. So that's 0, that's 1, whoops, and that's 1. So you get 110 when you subtract those two values, and then you bring down the next digit. But if there's not a digit, you annex in another 0, which is what we're going to be doing. So now I want to see how many times does 125 go into 1,100. There's a couple ways you could guess and check. You could count up. Counting up is probably the easiest way. So if you count up, you end up finding out that it goes in 8 times. You multiply 125 by 8, and you get 1,000. Once you get 1,000, you do another subtraction problem. You get 100. And you keep going in this long division until this becomes a 0, until you're left with nothing. I'm still left with 100. I bring down my next digit. If there isn't a digit, you annex in a 0. I bring down another 0. How many times does 125 go into that? By counting up, we can figure out it goes in 8 times. So then I do 8 times 125, which is 1,000. And I subtract these two fellas, and I get 0. Once I get to that point, that means I'm finished. Okay, so 36 over 125, represented as a decimal, is a batting average of what we would say is 288. Okay, so here's your answer, 288. All right, so like I said before, if you did not understand that problem, you always have the option of going back and looking at things again. Let's go ahead and go to our next slide. So here it says, find the batting average of a hitter with 22 hits and 80 times a bat. This says you try. So I'm not going to go over this problem because it's just like the other one. What you would want to do is pause it, write down the problem, attempt it on your own, and then unpause it, because all I'm going to do right here is write out the answer for you. You check your own answer. If you miss it, go back and try to figure out where your mistake was, or you could always bring it to class the next time you see me and ask me about it. So this one, if you were to go through it, you would get a batting average of 275. All right, so hopefully you got that right. Let's go on to our next part. So what if the decimal doesn't terminate? Okay, so writing a repeating decimal, a decimal expansion that repeats the same digit or group of digits forever, is called a repeating decimal. So here we have a couple examples. This one, I have 4.8333, and you see that 3 repeating forever. So the way that we would do this with math is we'd put a line just over the digit that is repeating. In this case, it's the 3. Down here, you see we have 0.181818 and so on. So we put a line over the 1 and the 8 because those are the digits that are repeating. So just like before, if you wanted to find how to write this as writing a fraction as a decimal or a rational number as a decimal, what happens when it starts repeating? If you have a calculator, you do this and you see the digits repeating. It's not very difficult. But what if you didn't have the calculator? Well, you set it up just like we did before. So I have a long division problem. So I have 27 divided by 99. This goes very much like that other one. 99 is too big to go to 27, so I add my decimal, I annex in a 0. Be sure to bring that decimal straight up. And now I'm seeing how many times 99 goes into 270. 99 is a nice number to work with because it's so close to 100. So how many times does 100 go into that? Well, it goes in twice, and then I'm just doing this problem. 2 times 99, you get 198. And then you do the subtraction like we did before, and you get 72. And then I go through the whole process again. I have to add another 0, bring that down. How many times does 99 go into that? It goes in 7 times. Whoops, that's a 7 for those of you that are questioning that. Do my multiplication problem. I get 693. Subtract these two values, and I get 27. Now that 27 ought to look familiar to you because remember, that was that original number. So let's see what happens here. I put in another 0. I'm going to drop that down. I'm seeing how many times that goes into 270. It goes in 2 times. Multiply again. I get 198. Subtract again, and oh look, I get a 72, which is the number I got before. I need to annex in a 0 to bring down. I wish my pen were working better. Apologize for that. How many times does it go into that? It's 7, and then I multiply and get 693, and you can see I'm running out of room here, but that leaves me with 27, and once again I'm doing the whole process again. So hopefully at that point you notice that that 27 is going to continue coming up. It's going to be 0.27, 0.27, or 0.27, no point in between it. 0.27, 27, 27, and those are the digits that's repeating. So the way that we write that in math is we would do 0.27 with a line over the values that are repeating. So right here, we'll put a 0 in front of it, just to be technically correct. Right there, that is how you write this number, 27 over 99, as a decimal. So here is one for you to try. I'd like you to give that a shot. So you want to pause now and try the problem, and then when you're done, unpause it, and you will find out that the answer is 0.916 with the 6 repeating. Okay, hopefully you found that. If not, go back and try to find your mistake. I got one other problem for you to look at here, so let's go ahead and jump into this. Writing an equivalent fraction. So this is going the other way. I'm starting with the decimal, and I want to write that as a fraction. So I have write 1.345, or 1 345 thousandths, as a mixed number in simplest form. Okay, so the first thing that I want you to do with this is I want you to write this number over 1. It's not technically a fraction because you don't get decimals in fractions, but you're kind of making it go ahead and look like the fraction. So I have 1.345 over 1. And the next thing that I have to think to myself is, and hopefully you learned about your powers of tens, is what would I need to multiply this top number by to get rid of this decimal? In other words, I want it to move to the right 1, 2, 3 times. So I would multiply, if I wanted to move 3 times, I'd multiply by 1,000. Now, in order to keep this fraction equivalent, if I multiply the numerator by 1,000, I have to also multiply the denominator by 1,000. So I multiply both the numerator and the denominator by the same value, and when I do that, I get 1,345 over 1,000. So there's a fraction, okay? There's no decimal or anything like that. It's a fraction that you would go through the same processes that hopefully you already know how to do. So I'm going to look at that. First thing is, let's identify the greatest common factor between 1345 and 1,000, which is the number 5. You may remember this being called a GCF. So I divide the top and the bottom by that GCF. And after I do that, I get 269 for the top number. For the bottom number, I get 200. Now, there is no number aside from 1 that these are both divisible by, so that means this fraction is in simplest form. Up here, it asks you to write it as a mixed number. What that is when you have an improper fraction, you need to write it with a whole number and a fraction. So I see how many times does the denominator go into this. 200 goes into 269 one time, and that leaves me with a remainder of 69, and then I keep the same denominator. So I get 1 and 69 200ths, and that is 1.345 as a mixed number in simplest terms. So hopefully you got that. Here is one for you to check on your own. Go through that, pause now, write down the problem, and hopefully after you finish, you find that you get 1 and 21 over 50. All right, so that's your answer, and that is all I have for this particular lesson. Hopefully you've taken good notes, because if you recall, I will not help you in the classroom if you do not have your notes. So you writing out these notes is going to be very, very, very important. I will see you all in class. Thank you.